Welcome to the CAMWorks Nesting webinar, and thank you for joining us. Today, I'll introduce you to the latest in low-cost, state-of-the-art nesting technology, CAMWorks Nesting. CAMWorks Nesting includes powerful features normally found in far more expensive nesting systems at an incredibly low price. CAMWorks Nesting is a full-featured nesting package seamlessly integrated inside SolidWorks that allows you to quickly and easily nest your SolidWorks parts and assemblies. CAMWorks Nesting is a full-featured automatic nesting module for SolidWorks, and it's smart, easy, and efficient. CAMWorks Nesting is seamlessly integrated inside SolidWorks and automatically creates nested layouts as a SolidWorks assembly. CAMWorks Nesting uses the latest fully automatic True Shape nesting technology and helps you to create nested layouts of both your SolidWorks parts and assemblies. CAMWorks Nesting creates fully associative nested layouts, so if your part model changes, the change to the component will be instantly reflected in the assembly. Using CAMWorks Nesting, you can nest both flat and 3D sheet metal parts, and the flat patterns of the 3D parts will be used automatically for nesting. CAMWorks Nesting can help you to optimize the use of your material, increase productivity, and reduce scrap, saving you thousands of dollars. CAMWorks Nesting runs right inside SolidWorks and uses the same user-friendly interface. There are online videos to help you get started, and there's also a CAMWorks user guide and tutorials to help you get up to speed quickly and take full advantage of your CAMWorks nesting software. CAMWorks Nesting is seamlessly integrated inside SolidWorks and supports industry standards including IGES, STEP, ASIS, and Parasolids. And CAMWorks Nesting can be used to nest solid models from many different types of CAD systems, including Pro Engineer, Unigraphics, Solid Edge, and Autodesk Inventor, just to name a few. CAMWorks Nesting uses the latest True Shape nesting technology from Geometric's NestLib software, which is one of the fastest full-featured automatic nesting libraries available today. You can use CAMWorks Nesting to nest both your SolidWorks parts and assemblies automatically using the correct material even if the parts are of different thicknesses. CAMWorks Nesting automatically creates SolidWorks assemblies of the nested layouts that are fully associative with the part models, and if multiple layouts are required, you can automatically create either multiple configurations in one assembly file or separate assembly files for each layout. Here's a look at the easy-to-use CAMWorks Nesting user interface. The Part Data tab has the parts list at the top, and it populates automatically from your SolidWorks assembly, the part files you currently have open, or automatically from a folder containing SolidWorks part models. Under the list, the thickness, quantity, and material types are also automatically populated. To the right of the parts list is a part preview window, and working around clockwise, we can specify a grain direction for each part and specify fast or optimal nesting with a time limit. We can also create separate SolidWorks assembly files or use the default of creating multiple SolidWorks configurations within a single assembly. We can specify the part-to-part and part-to-sheet distances and a step angle or part angle for each part. CAMWorks Nesting also has the ability to do automatic part-in-part nesting, which means that it can automatically nest smaller parts in the voids of larger parts to maximize material usage. As we could see in the user interface, using CAMWorks Nesting, you can specify the grain direction for each part, specify a step angle or increment angle, or input specific discrete angles for the nesting of each part. CAMWorks Nesting also lets you select either fast nesting or optimal nesting with a user-specified time limit. Now that we've looked at the Part Data tab and its features, Let's look at the Sheet Data tab, where we specify the material that will be used for nesting. At the top of the Sheet Data tab is a list of the sheets or material that will be used during nesting. The material list can be populated automatically from a customizable material library. Under the list, the thickness and material types are populated automatically, and the user can specify the quantity of each type of material that they have available for nesting. To the right of the material list is a sheet preview window, and below there is a drop-down menu for specifying the grain direction for each sheet on the list. In addition to using standard sizes of material from the customizable material library, the user can also specify a custom size and type of material. A DXF file can also be used for custom material shapes and sizes. Let's review the features available to us through the Sheet Data tab of the CAMWorks Nesting user interface. The user configurable material libraries of standard sheet sizes and material types can be used to automatically populate the material list based on thickness and type. Custom material sizes and types that are not in the library can be specified by the user to take full advantage of remnant material. And DXF files can also be used to define unique material shapes and sizes. Lastly, the grain direction can also be specified for each material type if it is critical to create the proper nest. It's time for a live demonstration of CAMWorks Nesting, and so now, let's go manufacture. Let's begin with a part model that represents a part we might want to nest. Here's a sheet metal part designed in SolidWorks. Before we begin nesting, notice how CAMWorks Nesting is seamlessly integrated inside SolidWorks. Once the CAMWorks Nesting add-in is installed, the CAMWorks Nesting menu appears, and I can simply select Create a Nesting Job from the menu to begin the process. Notice how the SolidWorks part I had open was automatically added to my parts list for nesting, and a preview of the part appears in the preview window on the right. The thickness and material type are also automatically selected from the SolidWorks part file. In addition, if I move the box, we can see that the part has been automatically unfolded in preparation for nesting. Here I can specify the quantity of parts I want to nest. For this example, I'm going to nest a quantity of 100 parts. Here I can specify the distance I want between the parts and the minimum distance from the parts to the edge of the sheet. Now that I've specified the quantity of parts, I'll switch over to the Sheet Data tab to describe the material I want to use for nesting. By pushing the Add Sheet button, the standard material size from my material library is automatically added to the list. Here I can specify the number of sheets of material I have available for nesting. For this example, I'll specify that I have 10 sheets of material available. I could also specify the grain direction for the material and for the part, but if grain direction isn't important, I can simply leave it set to none. Here, I also have the option to create a separate assembly for each nested layout, but by default, CAMWorks Nesting will automatically create multiple configurations in a single assembly file, which is a terrific feature. Now I'll select OK to begin the nesting process. Watch as CAMWorks Nesting automatically creates a SolidWorks assembly with the nested layout. CAMWorks Nesting also creates a report automatically to show us how many of the parts have been nested and the total utilization of the material. In the assembly, if I go to the SolidWorks Configuration tab, I can see that CAMWorks Nesting has automatically created a configuration for each of the nested layouts based on the total quantity of parts I specified. Now that we've seen how CAMWorks Nesting works for individual parts, let's take a look at how CAMWorks Nesting is used to nest SolidWorks assemblies. Here's a model of a fully assembled bookshelf inside SolidWorks. Using CAMWorks Nesting, I can begin by creating a new nesting job. CAMWorks Nesting instantly populates the parts list with all the parts in the assembly. I can click on each part in the list and see a preview of the part in the Part Preview window. And the corresponding part in the assembly is also highlighted. For this example, I'll suppose that I want to create 6 sets of bookshelves, and I'll input the quantities required. I can use my Control and Shift keys to select and change multiple parts in the parts list. Now that I've specified the quantity of parts, I can input the desired part-to-part distance and part-to-sheet distance. Next, we'll go to the Sheet Data tab and use the Add Sheet button to automatically add the standard sheet sizes from the library. Underneath the list, I can specify the quantity of sheets available for each of the materials used. In this case, I'll leave the default quantity to 10 and simply press OK to begin the nesting process. CAMWorks Nesting will automatically begin building an assembly file containing my nested layouts. Once the assembly is complete, a CAMWorks Nesting status report is automatically generated to show me the number of parts and utilization of my material. I'll select the SolidWorks Configuration tab. Under the Configuration tab, I can see CAMWorks Nesting has automatically created all of the layouts required to build the 6 sets of bookshelves I've requested. Now that we've seen CAMWorks Nesting working in both part and assembly mode, let's look at how CAMWorks Nesting can be used to nest a group of dissimilar parts. In this example, an assembly of a group of metal parts has been created. Using this assembly, we'll begin by creating a new nesting job. All of the parts are automatically added to the parts list, and the material types and thicknesses are automatically extracted. The parts list can be sorted based on the thickness, quantity, or angle. The quantities and other parameters of each part can be entered by double-clicking in the parts list. Parts data for multiple parts can be entered by using the Shift and Control keys. The step angle is the step angle or increment the part can be rotated for nesting. 90 degrees indicates that the part can be rotated to 0, 90, 180, or 270. We can also specify discrete angles for a part to be rotated. For example, 45, 90, and 180 only. The normal face lets us choose which face we want on top for nesting. Parts in the parts list can be selected and deselected, and only the selected parts will be nested. Multiple selection and deselection can be done by pressing the space bar. Moving over to the Sheet Data tab, we can see the thickness and material fields are automatically populated and extracted from the parts list. Standard sheet sizes can be selected from the User Configurable Material Library, and by pushing the Add Sheet button, they are automatically added to the material list. Custom sizes can also be entered by the user and added to the list. Of course, sheets can be deleted from the list using the Remove Sheet button. To add more sheets, we can click on the Select to Add Sheet row in the list and then use the Add Sheet button. Now we'll select multiple sheets using the Shift key and specify a quantity of 10 available sheets for some of the sheets in the list. We'll also change the material for the sheets. Let's change the material from steel to aluminum. Remember that the parts are actually supposed to be made of steel, which matches the SolidWorks part models. Going back to the Part Data tab, here we can optionally create separate assembly files for each layout, but by default, multiple configurations will be created in a single assembly file. Let's specify a part-to-part distance and a part-to-sheet distance. And notice here where we can specify optimal nesting with a time limit. We'll set it back to fast nesting for this example. And the nesting job can also be saved as a part of the SolidWorks assembly or part file. The Save Nesting job is loaded automatically when you select Create Nesting Job, and you can see that all the previous inputs have been maintained on both the Part and Datasheet tabs. If I try to select OK to begin nesting, you'll see that CAMWorks Nesting includes error checking with intelligent error messages. If we try to use the wrong material for nesting, an error will be posted. I'll change the material back to steel as it should have been based on the SolidWorks part files. And then I'll press OK to begin the nesting process. CAMWorks Nesting will automatically begin building the SolidWorks assembly. The layouts are created and the nesting summary file appears automatically. As we've seen, multiple configurations are created automatically for each of the nested layouts, even for different thicknesses of material. Here's the various layouts in the SolidWorks configuration tree. Now let's look at how CAMWorks Nesting can be used to nest parts in a folder. When SolidWorks is first opened, the only option under the CAMWorks Nesting menu is to nest by a folder. I'll begin by navigating to the folder containing the SolidWorks parts I want to nest. Once I select the folder, CAMWorks Nesting will automatically create a SolidWorks assembly of all the parts in the folder, and a nesting parts list is generated automatically. I can input the desired quantity for each part in the list. In this case, I'll specify a quantity of 5 for each of the parts in the list. I can sort the parts list by material, thickness, or any other field. I can also change the step angle for each of the parts. In this case, I'll specify 10 degrees for each of the parts except for the last part in the list. For the last part listed, I'll change to part angle and specify a discrete angle of 90 degrees. This means that the last part listed will be nested only at a 90-degree orientation and won't be rotated. Next, I'll input the part-to-part distance and the part-to-sheet distance. Now I'll go over to the Sheet Data tab to describe our material. I'll enter a quantity of 10 for each of the sheets in my material list. Next, I'll use the Add Sheet button to automatically add the standard size sheets to my material list. Notice how the types of materials and the thickness of materials are carried over from the parts list automatically. Now I'll press OK and the nesting process will begin. CAMWorks Nesting automatically creates a SolidWorks assembly file, and a summary report is generated automatically. Here's the results of my summary report. All of the parts have been nested. Notice the part-in-part nesting that was generated automatically by CAMWorks Nesting. I'll go to the configuration tree, and again, we can see where each of the layouts has been created automatically and added to the SolidWorks Configuration Manager. Because the SolidWorks assembly is created automatically, I can edit the assembly if I want to change the layout. I'll suppose in this example that I don't want the smaller parts nested inside the larger parts. I'll drag the parts over on the sheet and place them in their desired locations. Now that I have them placed in their desired locations, Let's look at how CAMWorks Nesting can be used in combination with CAMWorks. I'll begin by adding the parts to the CAMWorks Parts Manager. I can select just one of each of the parts and then use the Add All Instances button to add all of the identical parts automatically to the CAMWorks Parts Manager. Now that all of the parts have been added, I define my stock using the Stock Manager. I can use the sketch that was generated automatically from CAMWorks Nesting to define my stock. I select the sketch, tell it I want to put it around all the instances of the part, and then select OK. Next, I'll use CAMWorks Automatic Feature Recognition to automatically recognize all of the machinable features on the parts. Then I'll use Generate Operation Plan to generate all the operations to machine the part automatically. Next, I'll generate all the toolpaths and then use the Simulation button to simulate the toolpaths that have been created. The part has been programmed, and now I'm ready to generate code for my CNC laser, router, or water jet. I trust you're beginning to understand the power of CAMWorks Nesting. So if you want to increase material optimization by as much as 60%, improve your utilization and increase your productivity, reduce scrap by as much as 70%, and reduce rework due to design changes, get CAMWorks Nesting today. And now, let's go manufacture.